Modern aircraft have thousands of components and systems that need to be recurrently inspected or replaced. To keep the fleet airworthy, maintenance planners cluster maintenance tasks into work packages that are performed in regular hangar maintenance checks. In addition to regular maintenance checks, many other tasks need to be performed outside these work packages and scheduled one by one, increasing the complexity of the aircraft maintenance planning process. These non-routine tasks, including unexpected faults, follow-ups from inspections or crew complaints, have a disruptive nature since they may arise unexpectedly, demanding a constant update of the maintenance schedule. The challenge is even greater since, although there's some room to address unexpected tasks, for stability reasons, the maintenance schedule cannot be fully changed. Furthermore, implementing the condition-based maintenance concept for a fleet of aircraft and scheduling associated tasks based on probabilistic prognostics and diagnostics of the component's health will increase even more the complexity of recurrently scheduling maintenance tasks. Automated solutions are needed to address this challenge, to optimally schedule maintenance tasks and hangar checks, and thus fully exploit the benefits of condition-based maintenance. ReMAP presents a maintenance decision support tool that helps planners optimizing the allocation of maintenance tasks to maintenance opportunities. The tool uses prognostics health management algorithms to calculate the remaining useful life of components and continuously produces a multiple-week task schedule for a fleet of aircraft by considering the resources available, the maintenance policies, the fleet availability needs of the airline for commercial flights, and the maintenance opportunities. So how can the ReMAP Maintenance Decision Support Tool help planners in their daily lives? ReMAP Maintenance Decision Support Tool helps planners to deal with all the information and solve the complex scheduling problem for a fleet of aircraft. AI-based algorithms represent a computer agent that learned from simulations by repeatedly making scheduling decisions and assessing their value, similar to the way humans learn. The agent reacts to new information when this information is made available. Regarding the prognostics-based tasks, the agent reads prognostics health information to generate a belief of the health state of each aircraft in the fleet and determine the urgency for a maintenance intervention. Using past experience, it prescribes the best scheduling action in a matter of seconds, and therefore, it can adapt the maintenance schedule to new health conditions in real time. In order to help schedulers to interpret prognostics health information, visualize the proposed tasks schedule, and adapt it if needed, a user-friendly interface was developed with input from experienced aircraft maintenance schedulers. Together with the solutions for continuous systems health assessment, the tool is being tested in an operational environment for 6 months. Follow us to know more about the Maintenance Decision Support Tool and the results we are obtaining.